guys, today we're doing velocity as a rate of change. It might sound new, but it's not. So when we look at displacement measures both distance and direction along a line. For you to remember, that is the same as average velocity, which we already covered. You probably remember my little sketch here. So we're trying to find the average velocity between these 2 points right there. And by the time you find the slope of the secant line, that's, voila, your displacement right there. That's the average velocity. And we're also doing instantaneous velocity, which measures both speed and direction along the line. So, and that's just the derivative. Okay, this is my little cute picture right here. So there's the picture, we're finding the velocity at that specific point. It's not the average anymore, it's the instantaneous velocity at that one specific point. So by the time you find the slope of the tangent of that line at that point, that's the derivative. Okie dokie. So here we're going to do 4 examples. Sorry. But they're fairly easy and it's like a review over what we've done before. Okay, so we have a particle is moving along the line. Its displacement in millimeters after t seconds this is the function. Find the average velocity over the interval 7, 10. Okay, so I have my function here right at 10. So remember, what is y when x is 10? So I will put this on there. So what is y when x is 10? So x is 10, y is 83. And what is y when x is 7? Right there at 32. So the formula when we're looking for average, an easy way to remember, it's just the slope formula. But if you remember a couple, previous videos, we did right there, the average rate of change, f of b minus f of a over b minus a, or the difference in y over the difference in x. And that's what we're going to do. So 83 minus 32, that's the difference in y, over the difference in x. So 10 minus 7. And here I have 83 minus 32. I have 51. 10 minus 7 is 3. 51 divided by 3, 17. And the unit will be millimeters per second. So now the next one. So this is the concept. We have the same or a similar scenario. Now we're finding the average velocity between t equals 1 and t equals 1 plus h. So we're going to do, we're still following the same formula. You know, I'm going to have to find y when x is 1 plus h. And I'm going to do everything here off to the side, and then I'll bring it back together. So I will replace 1 plus h right there for t. So negative 7, 1 plus h, plus 1. And here, I will do the binomial expansion to where I square the first one. 1 times 1 is 1. Plus I double 1 times h. So it's 2h. And then I square the last one. So h squared plus 1. Distribute the negative 7. Combine like terms. So I can combine these two. And I'll go ahead and put everything in order, just because that's what I like to do. You don't have to, but I just like, it just looks better that way. Okay, and the other one I would definitely need is y when x is 1. So go ahead and replace or substitute 1 for t. And here you have -6. Okay, now we bring it all back together. So s of 1 plus h minus s of 1 over 1 plus h minus 1. Go ahead and substitute this whole thing right there for that. -7h squared minus 14h minus 6 minus s of 1 is -6. 1 minus 1 is 0, so I just have h left over. Let's simplify. -6 and 6 is 0. Go ahead and factor h out from the numerator. So -7x, not x, it's h. H squared divided by h is -7h. -14h divided by h is -14. Now go ahead and simplify that. And that should be your final answer. I'm going to write it over here. So it's -7h minus 14 millimeters per second. Oh, per hour. Sorry about that. So we're going to move on to instantaneous velocity. We have the displacement right here, given by the equation. Find instantaneous velocity at t equals 3. Okay, so now, since we're trying to find the instantaneous, I'm going to find the derivative using limits. So here's the formula from a couple days ago. And that's the formula I will use. Okay. So I have to find s of 3. So go ahead and substitute 3 for t right there. This one is easy. Now the other one, we will do 3 plus h and go ahead and substitute that. We're going to expand the binomial here. So you double the first one. Sorry, you square, you multiply, and you double. So 3 times h is 3h. You double, it's 6h. And then you square the last one. And then the final step on this one, you just need to distribute -5. Okay. So the formula is the limit as h approaches 0 of s of 3 plus h minus s of 3, everything over h. Since I already found all of that right here, I'll just go ahead and substitute that in the formula. So as I'm rewriting, I'll go ahead and put that in order. You don't have to, I just feel better when I do it. So minus S of 3 is negative 45. Two negatives make that a positive. All right, everything over H. Combine like terms. Negative 45 and positive 45 add up to 0. And then I'll go ahead and factor H out. Simplify H. And here I have the limit as H approaches 0 of negative 5H minus 30. And then at this point, you go ahead and you substitute 0 for H right there. And that will give you negative 30. What's the unit here? Centimeters per second. I want to do one more just because. So you know you have a particle moving along a line, its displacement in meters after t hours is. So I'm just going to give you the function so we don't have to write a whole bunch. So we're finding the instantaneous velocity at t equals 4. So we will definitely use the same formula that we just did on example 3. The reason why I wanted to do this one is because we have a cubed right there on the exponent. Since I will have to do the binomial expansion on that one, I'll go ahead and write the formula down. It will come in handy. Okay, so I have to find S of 4 plus H. So go ahead and substitute that for this H and also, T, and also this T right here. Remember the negative. So right here, I will definitely apply this formula so I can expand this binomial. And because it's cubed, you know, it's just nice if you go ahead and memorize that formula. So I will go ahead and cube the first one. Plus 3 times the first one squared times the second one. So here we're labeling A and B, okay? You probably already know this, but and then you distribute 6. Okay. So I have 48H, 12H squared. Distribute this negative right here. Combine like terms, and as I'm combining like terms, I'll go ahead and organize, put that in order from highest exponent to least exponent. So I have negative h cubed. Combine them, I have negative 42 h minus 40. Okay. Oh. And now I definitely need S of 4. This one is easy. I can just punch that in the calculator. Negative 4 and the darkness. So I have negative 40 right there. So what is y when x is 4? Y is negative 40. All right, now I have everything I need to start my problem. So limit as h approaches 0, I have that minus that, everything over h. Substitute all that for s of 4 plus h. Minus, I have negative 40 right there. Everything over h. When you add these two together, you have 0. Factor h out. Simplify h. When you divide, you get 1. And then at this point, you go ahead and you substitute 0 for h. Here I have 0. Here I have 0. My final answer will be negative 42 meters per hour. Woof! We got this.